Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider and you are watching Learn and Teach by Sir Ayaz. So I will continue my video session for the past papers and this time I have selected 0620 variant 41 and it is May-June 2023. You know this is paper 4 theory extended version. The timing for this paper is 1 hour 15 minutes. You must answer on the question paper. No additional materials are needed. The total marks for this paper is 80. Periodic table is printed in the question paper. So let's start the paper. This is question number 1. Some symbol equations and word equations A to J are shown. So from A, B, C, D, E, F, G, H, I, J. You can see there are different symbol and word equations. Use the equations to answer the questions that follow. Each equation may be used once, more than once, or not at all. A. Give the letter A to J for the equation that represents a neutralization reaction. Remember, a neutralization reaction involves the reaction between H positive ion and OH negative ion, and we will get H2O. So here we have B in your answer. So B will be the answer for this part. B, a precipitation reaction. What is a precipitation reaction? Precipitation reaction involves the formation of insoluble solid. So if you look at all the reaction equations, in equation A, I can see this FeOH whole thrice, which is iron 3 hydroxide. It is insoluble in water, which means it will form precipitate, meaning it exists as solid. The other equations, B is neutralization reaction, C is organic reaction, D is also organic reaction, E organic reaction, F displacement reaction between chlorine and aqueous potassium iodide, G this is the fermentation reaction, H organic reaction, I decomposition reaction, J this is a reaction for photosynthesis. So automatically A will be the right answer for a precipitation reaction. C, the formation of an ester. If you look at these choices, you can easily see that the reaction between ethanoic acid and ethanol results in the formation of ester, which is ethyl ethanoate. This is ester plus water. So H must be the right answer for number C. D, photosynthesis. It's very easy. Photosynthesis reaction involves carbon dioxide and water. The products will be glucose and oxygen. So G will be the answer in this case. Next one, fermentation. Fermentation reaction involves the conversion of sugar into ethanol and carbon dioxide. And if you look all the choices here, we have only one reaction which shows this reaction, which is G here. This is glucose and the product is ethanol and carbon dioxide. So G will be the right answer for E. Last one, cracking. Cracking involves breakdown of long chain alkanes. In order to get, we have two possibilities. smaller alkane plus alkene or alkene plus hydrogen gas. So let's see the choices. If you look at all the choices, you will find this reaction as cracking. Number D. This is ether decane, eth decane, and it's broken down to produce octane. This is octane, and butene. This is butene. This is octane, and this one is butene. So alkane and alkene. So this must be the answer for this choice for number F. So write D here. Number 2, A. The symbols of the elements in period 2 of the periodic table are shown. We have Li, Be, B, C, N, O, F, and E. Let me show you these elements in the periodic table. This is the periodic table. You see these are in the second period. This is second period. Li, Be, B, C, N, O, F, N, E. So these are from second period. Use the symbols of the elements in period 2 to answer the questions that follow. Each symbol may be used once, more than once, or not at all. Give the symbol of the element that, number 1, makes up approximately 78% of clean dry air. This is very easy. You know that nitrogen is a gas which makes up 78% of clean and dry air. So N will be the answer for this question. Number 2, contains atoms with only 3 electrons in the outer shell. Coming back to this periodic table, you can clearly see that in the second period you have boron, which is an element which contains 3 electrons in its valence shell because it is in group 3. Group 3 means it must have 3 valence electrons. So you can write B here. Number 3, contains atoms with only 9 protons. Simply you have to look at the proton number. So if you look at this periodic table, you will find fluorine as having 9 as its proton number, which means it must have 9 protons. So F is the answer for number 3. Number 4, exists as graphite. Graphite is the allotropic form of carbon. So straight away you will write the symbol C here. Number 5 is an alkali metal. You see, first element, that is Li, belongs to group 1. These are alkali metals. Group 1, alkali metals. So you will write the symbol Li here. Number 6, only has an oxidation number of 0. This element must belongs to group 8. Here we are having group 8. They have 0 as their oxidation number. So neon will be the answer for this part. So I will write Ne. B, boron B has 2 isotopes. 1, state the meaning of the term isotopes. They are asking the definition of the isotopes. You know, they have different atoms of the same element with the same number of protons or proton number and different number of neutrons or nucleon number. So I will write different atoms of the same element with the same number of protons or proton number but different number of neutrons or nucleon number. Number 2, table 2.1 shows the relative masses and the percentage abundances of the two isotopes of boron. Here we have relative mass of isotope 10, 11. Percentage abundance for 10 is 20, for 11 is 80. Calculate the relative atomic mass of boron to one decimal place. What you have to do, you have to multiply the relative mass by the percentage and add up these values. So 10 multiplied by 20 bracket plus 11 multiplied by 80 bracket close divided by 100. Let's do the calculation. So 10 multiplied by 20 gives 200 plus 11 multiplied by 80 gives 880. So finally 200 plus 880 divided by 100 gives 10.8. 10.8 will be the relative atomic mass for this boron. Question number 3. This question is about ionic and covalent compounds. A1. Sodium reacts with oxygen to form the ionic compound sodium oxide. The electronic configurations of an atom of sodium and an atom of oxygen are shown in figure 3.1. This is figure 3.1. We have sodium atom, we have oxygen atom. Ions are formed by the transfer of electrons from sodium atoms to oxygen atoms. Complete the dot and cross diagrams in figure 3.2 to show the electronic configuration of one sodium ion and one oxide ion. Show the charges on the ions. So first of all, you should know how many atoms of each of these elements involved in the formation of ionic bond. So we have sodium and oxygen. This is a symbol for sodium, symbol for oxygen. Sodium belongs to group 1. Here we have sodium. Valency for group 1 is +1. What about oxygen? Oxygen belongs to group 6. Valency is -2. So I will write +1, -2 here. Ignore the charges 1, 2. These subscripts will be exchanged 2, 1. So we'll get Na2O. This will be the formula for the compound formed between sodium and oxygen, which means that each of the sodium atom will be donating their valence electrons, and it means one oxygen atom will receive 2 electrons at a time. So let's show the valence electrons of sodium. Each sodium, after losing their valence electron, will be left with 10 valence electrons. Look at the proton number. 11 is a proton number, which means it has 11 electrons. Initially, sodium have 11 electrons. After losing this electron, it will be left with 10 electrons. So it's a positive ion. After losing one electron, it will acquire positive charge. So I need to show 8 more electrons. 2 electrons are already shown here. So 1, 2, 3, 4, 5, 6, 7, 8. So here we have all the electrons of sodium, and I will place plus charge here. What about oxygen? Oxygen. Here is oxygen. Proton number of oxygen is 8, which means it has 8 electrons. 8 electrons. So it has received 1 electron from the from each of the 2 sodium atoms. So now it has 10 electrons, which means it will acquire -2 or 2 minus charge. So in the valence shell, I have to show 2 electrons from the sodium atom. So here we have electron from sodium 1 and 2. Now let's show the valence electrons of oxygen. Look at the group number again, group 6. It must be 6. 6 valence electron for oxygen. 1, 2, 3, 4, 5, 6. So I will write 2 minus here. It has gained 2 electrons, and therefore it will acquire 2 minus charge. Number 2, write the formula of sodium oxide. I have just worked out the formula. I will do this again. Sodium, oxygen. Sodium belongs to group 1, +1. Oxygen belongs to group 6, -2. Ignore the charges, 1, 2. Subscript will be exchanged, so we will get Na2O. This will be the final formula for sodium oxide. B. Carbon dioxide, CO2, is a covalent compound. Complete the dot and cross diagram in figure 3.3 to show the electronic configuration in a molecule of carbon dioxide. Show outer shell electrons only. So CO2, meaning we have only one carbon atom. Look at the position of carbon here. Here we have carbon. This is carbon group 4, which means it has 4 valence electrons. Now I'm showing the key here on the right hand side. For carbon, I am using cross. For oxygen, I am using dot. So first of all, I will show the 4 valence electrons of carbon. 1, 2, 3, 4. What about oxygen? Oxygen belongs to group 6. Here it is. Here it is oxygen. 6 valence electron. Each oxygen atom having 6 valence electron, they will be sharing 2 of their valence electrons with carbon atoms. Reason, they need 2 electrons to complete their valence shell. So 2 electrons of oxygen for the right hand side, 1, 2, 3, 4, 5, 6. Left hand side, 1, 2, 3, 4, 5, 6. So this will be the final dot and cross diagram for carbon dioxide. C. The melting points of sodium oxide and carbon dioxide are shown in table 3.1. Table 3.1. This is the melting point of sodium oxide, 1275. Carbon dioxide, -78. Number 1, explain in terms of bonding why sodium oxide has a high melting point. It must be related to the strong electrostatic attraction or strong bond. Strong bond or strong electrostatic attraction. So it must be between the oppositely charged ions, between positive and negative ions. Number 2, carbon dioxide has a low melting point. State the general term for the weak forces that cause carbon dioxide to have a low melting point. It must be intermolecular forces. So write intermolecular forces. Next question. Oxygen is produced by the decomposition of aqueous hydrogen peroxide, manganese 4 oxide. MnO2 is a catalyst for this reaction. A, state the meaning of the term a catalyst. Catalyst increases the rate of reaction. As it's of 2 marks, so you have to tell something about the catalyst, that is remain unchanged at the end of the reaction. So you write increases the rate of reaction. Increases the rate of reaction. Next statement will be remain unchanged. Remain unchanged at the end of the reaction. At the end of reaction. Part B. A student adds powdered manganese 4 oxide to aqueous hydrogen peroxide in a conical flask as shown in figure 4.1. The mass of the conical flask and its contents is measured at regular time intervals. The mass decreases as time increases. This is aqueous hydrogen peroxide here, and we have powdered manganese 4 oxide. We have loosely fitting cotton wool plug. This is a balance. 1. State why the mass of the conical flask and its contents decreases as time increases. If you look at the reaction, what is happening? You have oxygen produced during the decomposition of H2O2. So you have H2O2, when H2O2 decomposes, it produces oxygen gas. It's a gas. So oxygen escapes from the apparatus. Oxygen escapes from the apparatus, or you can name the apparatus, that is conical flask. Number two, the rate of reaction is highest at the start of the reaction. The rate decreases and eventually becomes zero. Explain why the rate of reaction is highest at the start of the reaction. So at the start of the reaction, you have a higher concentration of H2O2. So there will be higher collision frequency in the beginning. This must be the reason. So you write concentration of hydrogen peroxide of hydrogen peroxide is highest at the start of reaction or you can even write there will be higher collision frequency or there will be higher collision frequency at the start of the reaction. Number three, explain why the rate of reaction eventually becomes zero. Definitely, hydrogen peroxide is used up or reacted or decomposed. Hydrogen peroxide is decomposed or reacted or used up. You can write any one of these. C, the experiment is repeated at an increased temperature. All other conditions stay the same. Explain in terms of collision theory why the rate of reaction is higher at an increased temperature. On this is of 3 marks. First of all, you will talk about the kinetic energy. That is, kinetic energy of the particle increases, then there is increase in the frequency of collision. Then you have more particles or higher number of particles having energy greater than or equal to activation energy. Kinetic energy of particles increases, and you can say increases the frequency of collision, increases the frequency of collisions between particles. Higher number of particles have energy greater than or equal to activation energy. D, the equation for the decomposition of aqueous hydrogen peroxide H2O2 aqueous is shown. This is a reaction. 2H2O aqueous gives 2H2O liquid plus O2 gas. 50 centimeter cube of a 0.2 mole per dm cube solution of H2O2 aqueous is used. Calculate the mass of O2 that forms. Use the following steps. Number one, calculate the number of moles of H2O2 used. So you have the volume of H2O2 and the concentration of H2O2. So we have a concentration 0.2 mole per dm cube, which means that it is 0.2 mole in 1000 centimeter cube. This is the relationship between dm cube and centimeter cube. So you'll write 1000 centimeter cube contains 0.2 moles. Therefore, 50 centimeter cube contains X moles. To the cross, we will get what? We will get 1000X is equal to 0.2 multiplied by 50, or X is equal to 0.2 multiplied by 50 divided by 1000. What we will get? 0.2 multiplied by 50 divided by 1000. 0.01 moles. Determine the number of moles of O2 produced. So how we will calculate the moles of O2 produced? Look at the equation. 2 mole of H2O2 produces 1 mole of O2. H2O2, 2 moles. Therefore, 0.01 moles produces X mole of O2. Do the cross. What we will get? We will get 2x is equal to 1 multiplied by 0.01, or x is equal to 0.01 divided by 2. 0.01 divided by 2, 0.005 moles of oxygen. Now you have the moles of oxygen, you can easily calculate the mass of O2. Look at the position of O here. Here's the periodic table, here is O, AR is 16, and we have 2 here. So MR of O2 is 2 multiplied by 16, 32. So you simply multiply 32 by 0.005. The formula is AR or MR into mass into number of moles. So what we will get? 32 multiplied by 0.005, 0.16 gram. This will be the final answer. E. State the effect on the mass of oxygen produced if the mass of powdered manganese 4 oxide catalyst is increased. It is acting as catalyst, so there will be no effect. Catalysts have no effect on the mass. It just speeds up the reaction. F. Oxygen can also be produced by the decomposition of mercury 2 oxide, HgO. The only products of this decomposition are mercury and oxygen. Write a symbol equation for this decomposition reaction. So it's of 2 marks, which means that we have to balance the equation. What is the formula of mercury 2 oxides given? HgO. Formula for mercury is Hg, and we know that oxygen exists in the molecular state, so we will write O2 here. Let's balance the equation. I need to write 2 here before 2HgO in order to balance the oxygen on the product side. So now for Hg on the product side, we need to put 2. Now the whole equation is balanced. Question number 5. This question is about electricity and chemical reactions. A. The electrolysis of concentrated aqueous potassium bromide using graphite electrodes forms hydrogen at the cathode, bromine at the anode. The electrolyte becomes aqueous potassium hydroxide. 1. State what is meant by the term electrolysis. Now, electrolysis, the word electrolysis is made up of 2 terms. We have electricity, electro means electricity, and lysis means breakdown. So in this process, there is a breakdown of ionic substance in the molten state or aqueous solution through the passage of electricity. So you write breakdown of an ionic compound in molten or aqueous state by the passage of electricity. Number two, state why graphite is suitable for use as an electrolyte. Now it contains free electrons because and due to this reason it conducts electricity, and graphite is also unreactive. Conducts electricity and graphite is unreactive. Number three, write an ionic half equation for the formation of hydrogen at the cathode. So this is the ionic half equation for the formation of hydrogen. It forms from H positive ion. So we have H positive ion plus electrons, and we will get hydrogen gas. Balance the equation. We have to put 2 moles of electrons. Number 4, name the type of particle responsible for the transfer of charge in the conducting wires. The conducting wires are solid substance. In solid substance, the conduction is due to the presence of free moving electrons. So it's electron. Number 5, name the type of particle responsible for the transfer of charge in aqueous potassium bromide. It must be ions. So we have free moving ions in the aqueous solution, which is responsible for the transfer of charge or conduction of electricity in the solution. Number 6, state the names of the products formed when electricity is passed through dilute aqueous potassium bromide using graphite electrodes. So at the anode, we will get oxygen, and at the cathode, we will get hydrogen. At the anode, we will get oxygen. The reason is that we have lower concentration of bromide ion. So that's why we'll get oxygen. The same reason is applicable to the cathode. We have lower concentration of potassium ions than H positive ions. So you'll get hydrogen gas at cathode. B, bauxite is an ore containing aluminium. Aluminium is extracted by electrolysis of purified bauxite in molten cryolite using carbon electrodes. Number 1, name the aluminium compound in purified bauxite. It is aluminium oxide. Number 2, state 2 reasons why cryolite is used in this electrolysis. Now it reduces the melting point of the electrolyte, which is aluminium oxide here, or it increases the conductivity of this electrolyte, or you can even write it is used as a solvent. So we will write any 2 from it decreases the melting point or operating temperature. Or it increases the conductivity. Of the electrolyte, or it is used as a solvent. It's acting as a solvent here. Number 3, the anode is made from carbon. Explain why the carbon anode has to be replaced regularly. The temperature is high during the electrolysis of aluminium. So oxygen produced at anode reacts with carbon and it forms carbon dioxide. So we will write carbon reacts with oxygen. Carbon reacts with oxygen and form carbon dioxide. Number C, hydrogen oxygen fuel cells can be used to produce electricity in vehicles. Number 1, write the symbol equation for the overall reaction in a hydrogen oxygen fuel cell. So the overall reaction is the formation of water from hydrogen gas and oxygen. So this will be the equation. H2 plus O2 gives H2O. Let's balance the equation. So I'll write 2 in order to balance oxygen. So we need to write 2 here also. Number 2, state one advantage of using hydrogen oxygen fuel cells instead of petrol in vehicle engines. It produces almost 3 times more energy than petrol, or you can say more efficient, and it does not produce carbon dioxide. It produces almost 3 times more energy than petrol, or fuel efficient. Or you can write it does not produce CO2, carbon dioxide. Moving to next question. Question number 6. This question is about sulfur and compounds of sulfur. Sulfur is converted into sulfuric acid, H2SO4, by the contact process. The process involves 4 stages. Stage 1, molten sulfur is converted into sulfur dioxide. Stage 2, sulfur dioxide reacts with oxygen to form sulfur trioxide. Stage 3, sulfur trioxide combines with concentrated sulfuric acid to form oleum, H2S2O7. Stage 4, oleum reacts to form concentrated sulfuric acid. A1, in stage 1, iron pyrites FeS2 can be used instead of molten sulfur. The iron pyrites is heated strongly in air. Balance the equation for the reaction occurring when iron pyrites reacts with oxygen in the air. So we have FeS2 plus O2 gives Fe2O3 plus SO2. So if I will balance Fe, so I need to write 2 here, 2 before FeS2. What about S? S becomes 4. Then we have 4SO2. So what about oxygen? We have 4 multiplied by 2, 8, 8 plus 3, 11. 11 oxygen. So this means that if we can take straight away 11 moles of oxygen instead of 5.5. 5.5 is not the whole number. 11 is the whole number. So 11 multiplied by 2 means we have 22 atoms of oxygen must be on the product side. So this should be wrong. And what if I will write 4 here instead of 2? 4 FeS2, then I will have to write 2 here. What about sulfur? 4 2s are 8. 8 2s are 16 for oxygen. 8 2s are 16. 16 plus 2 3s are 6. 6. 16. 16 plus 6, we will get 22. It's balanced now. Okay, number 3, name Fe2O3, include the oxidation number of iron. Fe2O3, what is the oxidation number of iron in Fe2O3. This is the formula for Fe2O3. If you look at the position of oxygen, here it is oxygen, it must be carrying -2, as it is more electronegative than iron, Fe. So I know the oxidation number of oxygen, I can use it to find the oxidation number of iron. There are 2 iron atoms, we have 2x plus 3 atoms of oxygen, 3 multiplied by -2 is equal to 0, as there is no charge on Fe2O3. So 2x minus x, 6 is equal to 0, or 2x is equal to plus 6, or x is equal to plus 6 by 2. We will get what? 3 plus 3. So the oxidation number of iron is plus 3. So I will write iron 3 oxide. Iron 3 oxide. B. The equation for stage 2 is shown. 2SO2 gas plus O2 gas gives 2SO3 gas. The forward reaction is exothermic. The reaction is carried out at a temperature of 450 degrees centigrade and a pressure of 2 atm. Using explanations that do not involve cost. Number 1, explain why a temperature greater than 450 degrees centigrade is not used. Forward reaction is exothermic. So it must decrease the yield of SO3. This is the reason we can't use 450 degrees centigrade, because forward is exothermic, it favors low temperature. So it decreases the yield of SO3. Decreases the yield of SO3. Number 2, explain why a pressure lower than 2 atm is not used. So if we decrease the pressure, then it will decrease the rate. So you write decrease the rate. It can even decrease the yield of SO3 also, or decrease the yield of SO3. C. When sulfuric acid reacts with ammonia, the salt produced is ammonium sulfate. Write the symbol equation for this reaction. We have ammonia, NH3, and we have sulfuric acid, H2SO4. The product is ammonium sulfate. What will be the formula of ammonium sulfate? Ammonium ion, this is the ammonium ion, NH4. Sulfate ion, SO4. The charge on ammonium ion is +1, sulfate is -2. Ignore the charges. These subscripts will be exchanged to 1. So we'll get NH4 whole to SO4. So NH4 whole to SO4. Let's balance the equation. Simply put 2 before NH3. It is balanced now. D. Lead-2 sulfate is an insoluble salt. Lead-2 sulfate can be made from aqueous ammonium sulfate using a precipitation reaction. Number 1, name a solution that can be added to aqueous ammonium sulfate to produce a precipitate of lead-2 sulfate. So you have to take a soluble salt of lead. So we have, what salts we have? We have a chloride, all chloride soluble, except lead, mercury, silver. So this can't be the right choice. What about sulfate? Sulfate, all sulfates are soluble except बेसन के लड्डू, बेसन बेरियम, के कैल्शियम, लड्डू lead. So this is also not the right choice. We are left with nitrate. All nitrates are soluble. All nitrates are soluble. So you can take lead nitrate or lead 2 nitrate. Number 2, write an ionic equation for this precipitation reaction, include state symbols. Now we have to write the ionic equation for the precipitation reaction which is happening between ammonium sulfate and lead 2 nitrate. So lead 2 nitrate, Pb is carrying +2 charge, nitrate -1 charge, 2, 1, ignoring the charges, 1, 2. So it must be PbNO3 whole twice aqueous. What about ammonium sulfate? This is a formula for ammonium sulfate. So I will write NH4 whole 2 SO4 aqueous. The products we are getting lead 2 sulfate PbSO4 solid plus and ammonium nitrate 2NH4 and O3. So in order to write the ionic equation, we have to open up the equation. Just write down their charges. For Pb, we have Pb +2, it's aqueous, plus 2 moles of nitrate ion, 2NO3 minus aqueous, plus 2 moles of NH4 ion, plus aqueous, 1 mole of sulfate ion, SO4 minus 2 aqueous, gives PbSO4 will remain as it is because it is in the solid state, and 2NH4 NO3 2NH4 positive aqueous plus 2NO3 aqueous. Remember, spectator ions will be cancelled out. Spectator ions are common ions on both sides of the equation. We have ammonium ion and nitrate ion. So we are left with Pb +2 aqueous plus SO4 minus 2 aqueous gives PbSO4 solid. This must be the final ionic equation. Number 3, the precipitate of lead 2 sulfate forms in an aqueous solution. Describe how pure lead 2 sulfate can be obtained from the mixture. So first of all, you need to filter, then wash the residue with distilled water or even with deionized water, then dry it in air. Filter, wash the residue with distilled water, then dry the residue, which is a crystal, in air. Moving to next question, number 7. This question is about organic compounds. A, butane reacts with chlorine in a photochemical reaction. This is a reaction C4H10 plus Cl2 gives C4H9Cl plus HCl. Number 1, state the meaning of the term photochemical reaction. The reaction uses ultraviolet light. Number 2, an organic compound with the formula C4H9Cl is formed when one molecule of butane reacts with one molecule of chlorine. Draw the displayed formula of two possible structural isomers with the formula C4H9Cl formed in this reaction. So you have to draw the isomers, possible isomers for C4H9Cl. So there are 4 carbon atoms. So either chlorine is placed at carbon number 1 or carbon number 2. So you can have either 1 chloro butane and 2-chlorobutane. It's only the position of chlorine that is different in both. We have 4 carbon atoms, 1, 2, 3, 4. So chlorine is at carbon number 1. It's up to you whether you want to place it on the right hand side or on the left hand side, but should be on the first carbon. There is chlorine. Let's saturate the carbon atoms with hydrogen. Place hydrogen. What about 2-chlorobutane? Again, we have 4 carbon atoms. 1, 2, 3, 4. We must have chlorine at the second carbon. So here is chlorine. Now saturating the carbon atoms. B. The structure of compound A is shown in figure 7.1. This is the structure of compound A, figure 7.1. Number 1, deduce the molecular formula of compound A. Molecular formula. So we have C, hydrogen and oxygen in it. C, hydrogen and oxygen. Let's count the number of atoms for each element. For carbon, 1, 2, 3, 4. So this C4. Hydrogen, 1, 2, 3, 4, 5, 6. H6. What about oxygen? 1, 2, 3. So C4H6O3. This must be the molecular formula of compound A. Number 2, there are 3 functional groups in compound A. Name the homologous series of compounds that contain the following functional groups. Carbon-carbon double bond, it's present in alkene. So I will write alkene. OH is present in alcohol. COOH is present in carboxylic acid. Number 3, state what is observed when compound A is added to aqueous bromine, aqueous sodium carbonate. Now, aqueous bromine decolorizes if there is carbon-carbon double bond present in it. So you can even write decolorize, decolorizes, or turns colorless. What about aqueous sodium carbonate? It reacts due to the presence of this COOH, the carboxyl group, acidic group. So you'll have fizzing or effervescence. Effervescence, fizzing, bubbling. Number 4, compound A can be used as a single monomer to produce 2 different polymers. Draw one repeat unit of the addition polymer formed from compound A. We need to draw the addition polymer formed from compound A. For your convenience, I am drawing the monomer. We have COOH, C double bond, CH, and here we again have H, and we have CH2OH. Now I need to draw repeat unit of this addition polymer. So repeat unit, in order to draw the repeat unit, exclude this double bond. So addition reaction, so this bond will be removed and you have only single bonds. COOH, H, CH2OH, H. Here we have single bonds in order to saturate it. So this will be the final repeat unit of the addition polymer formed from compound A. Number 5, compound A can be converted into a dicarboxylic acid. Name the type of condensation polymer formed from a dicarboxylic acid and a diol. It must be polyester. That's all for this video. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.